The narrative that AI is a software race has hit a physical wall. While headlines focus on new models and algorithms, the true bottleneck for growth isn't code, it's electricity. Data centers are no longer just server rooms. They have become energy giants consuming power densities comparable to small cities. The limiting factor for the next decade of AI breakthroughs is not how smart our chips get, but whether our grids can physically deliver enough megawatts without collapsing local infrastructure or forcing a pivot back to fossil fuels. This video explains why your electricity bill might rise and why tech giants are now buying nuclear reactors instead of just writing code. For years, the story was about intelligence scaling up through better software. But recent studies suggest we have already crossed into a strange psychological territory where humans willingly sacrifice guaranteed rewards for AI predictions. In one significant analysis, participants treated artificial intelligence as an ultimate predictive authority with 40% frequency, even when doing so reduced their earnings by nearly 30% on average. Yet while our minds are adapting to trust these digital inputs faster than logic dictates, the physical world is refusing to keep pace. We are witnessing a massive disconnect between software speed and hardware reality. The bottleneck for AI growth has shifted from innovation in code to hard constraints in power density, cooling physics, and grid stability. The visual shift here requires us to stop imagining data centers as simple server rooms filled with quiet fans. In the early 2010s, a standard rack consumed roughly 5 kilowatts of electricity. Today's high-density GPU clusters demand over 40 kilowatts per unit. This is not just an incremental increase, it represents a nearly 8-fold jump in energy density within 2 decades. A single modern campus now consumes more electricity than 100,000 homes simultaneously. When you multiply that by the sheer number of facilities being built, the scale becomes overwhelming. We are seeing data centers consume power densities comparable to entire small cities, creating a situation where local grids simply cannot absorb the load without significant upgrades or failures. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This physical reality has led directly to grid saturation in key tech hubs like Ohio, Oregon, and Georgia. Utilities in these regions have begun freezing new interconnections for data center projects because the transmission lines physically cannot handle the sudden spikes in demand from AI workloads. The result is that interconnection queues are now becoming longer than construction timelines themselves. A project can be ready to launch with full hardware inventory only to face a multi-year wait just to get permission to plug into the local grid. This creates a hard stop for growth where no amount of software optimization or algorithmic efficiency can overcome the lack of available megawatts on the wire. Faced with these renewable limitations and an unreliable grid, major tech players are pivoting to nuclear power as a necessity rather than an option. Microsoft has secured a 20-year agreement to restart the 3 Mile Island reactor by 2027, accelerating its completion from the original schedule. This is not corporate philanthropy, it is an engineering survival strategy necessitated by the failure of current infrastructure to support massive AI workloads. Similarly, Google and Amazon have signed deals for small modular reactors, though commercial deployment remains years away due to cost overruns and a lack of operational U.S. reactors. For now, this forces a reliance on natural gas in the interim while they wait for nuclear capacity to come online. The human cost of this infrastructure crisis is already visible at the utility meter level. The surge in demand has driven electricity costs up by 42% since 2019. This rate increase is not being absorbed by corporations, but is increasingly passed on to residents, creating a potential ratepayer revolt, where locals question why their bills are rising due to corporate infrastructure needs that have nothing to do with household consumption. The strain is real. Data centers are projected to consume approximately 1,000 terawatt-hours of U.S. electricity by 2030. To put this in perspective, this figure would surpass the entire annual electricity usage of Japan. By then, we will be consuming nearly twice as much power for these machines as we do today. As power density increases further, air cooling has reached its physical limit. The heat generated by high-performance chips must be dissipated instantly to prevent hardware failure. Liquid cooling technologies are becoming essential engineering requirements rather than optional upgrades. This shift is not just about efficiency. It is a fundamental change in how these facilities operate. If you cannot move the heat away from the silicon fast enough, the system shuts down or suffers catastrophic damage. The physics of thermodynamics now dictates the pace of AI development more strictly than any line of code ever could. We are entering an era where clean energy isn't just about sustainability. It is a prerequisite for keeping the lights on for the machines driving our economy. Every time you use an advanced AI tool, there is a massive physical cost occurring in real-time heat generation and grid strain. The pace of growth may slow down not because we lack better algorithms, but because building power plants takes years while software updates take minutes. This engineering bottleneck directly impacts local economies through rising utility rates and potential blackouts in areas where data centers cluster. We are witnessing a fundamental restructuring of our energy landscape to accommodate the physical demands of artificial intelligence. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.